Hello everyone, my name is Anirudh Bokka and I'm part of the Bio 54 Human Understanding class. Today I'm going to be talking about understanding how vaccinations work and the anti-vaccination movement. So before we begin, we're going to briefly talk about how vaccinations were first discovered. So specifically we're going to be looking at smallpox and the history of smallpox just because it was the biggest the most harmful disease that was eradicated by vaccinations. So, smallpox was a truly devastating disease for mankind. We're very, very fortunate not to have to worry about smallpox today. And no one really understands the origin of smallpox, but it is believed the first case was dated around 10,000 BC, where the first agricultural settlements took place in northeastern Africa or around Mesopotamia, Middle East. And then it quickly spread as trade and commerce began to Europe during the Middle Ages. And in the Middle Ages, it's been speculated that it was one of the reasons that caused the decline of the Roman Empire, which is such a large scale epidemic. Almost 7 million people was believed to have died. Were believed to have died from Europe. It spread to the New World through colonists and conquistadors, either from Spain or Portugal or from England. Um, and this affected and wiped out whole populations in the Americas. Um, uh, yeah. At smallpox peak in the 18th century, nearly 400,000 people died annually. And there's a picture on the right where they didn't really have um, a method to contain smallpox, so they just quarantined people and let them die. So Edward Jenner is truly the man. He was basically the person to invent inoculation vaccinations. So Edward Jenner was a man that grew up in Berkeley, England. He was very young and got apprenticed out to a man named George Harwick, who was a surgeon and had his own medical practice in the countryside. So, being in the country, he would often see milkmaids that would boast about never getting smallpox, this devastating disease everyone else got. Um, but they would get cowpox. And cowpox was very similar to smallpox, and they get lesions in the hand, but it was far less fatal. So Jenner, after was elected part of the Royal Society and did all this great scientific work, um, decided that in the early 1800s, late 1700s, he was going to test a theory he had where he would infect um, a small boy, an 8-year-old boy by the name of James Phipps, with cowpox. So um, Jenner took matter from a cowpox lesion on someone's hands, a milkmaid's hands, and infected a 8-year-old boy, James Phipps. Very small dose. The boy got sick, um, developed fever, but 9 days after the procedure, he recovered. And then Jenner inoculated the boy again with a smallpox lesion. And lo and behold, the disease didn't develop, and the boy was completely fine. And Jenner had concluded the first vaccination. Um, Jenner's was Jenner's work was incredible because it was one of the first real tries to attack a disease before infection, before the disease actually hit. And but what he failed to realize was vaccination doesn't guarantee a lifelong. One vaccination doesn't guarantee a lifelong protection from the disease. And Jenner's work was just the first step, huge step, into understanding proper mechanisms of why vaccines work and why subsequent vaccinations are needed. So we're going to look into how and why vaccines work. So first is the antigen response. So once a vaccine enters or once a disease enters the body, macrophages recognize the microbes. Microbes is another fancy way of saying bacteria or the disease. Antigens are located on the microbe's surface, and this usually causes an immune response by the body. Macrophages recognize microbes and therefore the antigens. Next, it gets passed on to lymphocytes. Lymphocytes are the ones that really recognize and attack the disease accordingly. So there are several types of lymphocytes. There are offensive T cells, which are responsible for destroying human cells that have already been infected. So the microbes have already entered the cell and they are causing havoc inside the cell already, and the offensive T cells destroy them. Defensive T cells guide and direct other cells and assist the killer cell T cells, which are the offensive T cells. And so they're basically just making sure this chemical goes where and this pathway is going on. B cells are the main ones that are the main response to destroying invading microbes, and they make antibodies specific to the antigens that the lymphocytes have recognized, and they bind to the microbes and destroy these microbes. Once the threat has almost been eliminated, some of the T cells and B cells are converted into through a metabolic pathway to become memory cells. These memory cells now remember and recognize the antigens invading the microbes, and then these cells are left in the body, and then they are capable of recognizing this disease if it comes through again. And I really apologize. I tried to play with this for hours. In fact, I'm turning this in late, but I can't get this to work. I'm so sorry. And the impacts of vaccinations are pretty straightforward. Some of the major diseases modern vaccinations take care of are mumps, measles, rubella, polio, tetanus, pertussis, influenza, and hepatitis. Vaccinations are done from birth in subsequent shots or sprays. Very rarely sprays, usually shots. And they allow B and T cells, the memory B and T cells, to develop. And subsequent shots make sure that you are growing these in small amounts to be ready. Small vaccinations are done so you are not bombarded with this disease and make sure that you can survive. So benefits of vaccination are pretty straightforward. Eradicated some huge diseases from the 20th century, from the 1900s to now. And I say this because some of these diseases are making a comeback in first world countries where vaccinations are available. And we're going to talk about why. But vaccines prevent more than 3 million deaths worldwide in a single year, and vaccines are extremely cost effective. It is easier to prevent a disease than to treat a disease because of hospital costs, cost of medicine, cost of doctors, patient stay, if you miss time from work or school. It's far easier to make sure the disease doesn't come up rather than trying to catch up and play. So here's a nice little graph. This is the United States mortality rates. And you can see measles, a clear drop after the vaccination has been introduced. From whooping cough, measles, scarlet fever, typhoid, these are just some of the few that vaccinations take care of. Okay, so now we're going to talk a little bit more about the anti-vaccination movement. So anti-vaccination advocates have been in practice since 1800s, basically ever since Edward Jenner invented or performed this experiment. The first real refusal of vaccines was discovery of a compound called thimerosal in vaccines. Thimerosal is basically a mercury-based product, which is a preservative to make sure that the vaccines don't deteriorate immediately. And people believe that small amounts of mercury were being injected into their bodies, which caused toxicity. Completely false and have been disproven, but people still like to believe it. But the main reason, or the main one, is from Andrew Wakefield, who said that autism was linked to vaccinations. Um, he has then been struck from practicing medicine forever. There's been tons of studies that were done to disprove the correlation, um, but social media and has kind of uh, warped this study, and the study has been disproven multiple times. So, running over time a little bit, but how we can fight the anti-vaccination movement is by making sure all your sources that are being read are referred by published journals, have been peer-reviewed and backed by scientific research with actual data. Most of the problems come from social media platforms where there's unproven scientific, sorry, you can't see my air quotes, studies that are not true at all. Don't trust these sources, and people should learn to trust their doctor. Another big reason is homeopathic medicine and remedies have been growing popular, and they don't affect vaccinations, or excuse me, they don't affect the disease and are not as effective as vaccinations. All right, that's the end of my presentation. Thank you very much for listening.